Welcome to Study Loop.
So this question, we have light entering the prism at point P and with an incidence angle of theta that in this diagram we call theta 1. And then some of it reflect at point Q with angle of refraction of 90 degrees. So this is point Q and this is the angle of refraction here. First, they want to know what is the index of refraction in terms of the incident angle. So theta 1 is the incident angle, theta 2 is the angle of refraction at the first surface. So we have the information that we have here is theta 1 is the incidence, theta 2 is the refraction at point P, theta 3 is the incidence at point Q, incidence at P, and theta 4 is 90 degrees is the refraction at point Q. So we have this information. Let me move this to the right, the left. So now we can use the law of refraction. So we have law of refraction point Q and at point Q, Q and Q. So we have in the second surface we have n sine of theta 3 is equal to sine of theta 4. We are assuming that outside is air. So this is n theta 3 equals to 1. And we can relate the interior angles here because they are complementary. So we have that theta 3 is equal to 90 degrees minus theta 2. So we can use this in this equation here. So we have n sine of 90 degrees minus theta 2 is equal to 1. This is equal to n cosine of theta 2. That we can also write this as n square root of 1 minus sine square of theta 2. Now we apply the law of refraction at point P here. So let's do this. At point P, we have sine of theta 1 is equal to n sine of theta 2. So this gives us sine theta 2 is equal to sine of theta 1 divided by n. And we can then use this in this equation here. So we have the equation n square root of 1 minus sine square of theta 2 is equal to 1. So this is the equation that we got from the refraction at Q. And we can use now the information from refraction at P to write in terms of the incidence angle. So this is n square root of 1 minus sine square of theta 1 divided by n squared equals to 1. And we can square both sides and solve for n. So n is equal to square root of 1 plus sine square of theta 1. We achieve what we wanted. We want to write the index refraction in terms of theta. Now for part B, they want to know what is the maximum value that the index of refraction can have. and if light emerges at Q, if the incidence angle at P is increased and decreased. So the maximum value is when sine squared is equal to 1. So and max is when sine squared is equal to 1. This is equal to square root of 2. That is 1.41. So this is the maximum refraction for B. For C, they want to know if light emerges if we increase the angle a little bit. So for a given value of n, if the angle of incidence at the first surface is greater than the θ1, so theta incidence greater of θ1, the angle of refraction there is greater than θ2, and the angle of incidence at the second phase is less than θ3. This means that the critical angle for the total, this means that the final angle in this surface here on θ3, so this means that θ3 prime will be less than θ3, and because of that it will be less than the critical angle, and this means that light will leave because we have that the angle is smaller than the critical angle, so we can let light pass through. The situation is different if we have an angle of incidence smaller than θ1, because now the signs the equality will change. So this means that θ3 prime will be greater than θ3, and this means that θ3 prime will be greater than the critical angle, and because it's greater than the critical angle, all light will be reflected. So here, light passes and all reflected.